Oh, check out these Ewoks here. These little Ewoks, they've built a catapult. They're going to fire off this projectile. Maybe hit some stormtroopers with it, right? Okay, so let's see. Let's check out. I want to show you guys how these Quadratics could model a projectile like this little rock that's going to be launched by these Ewoks. Sweet little assault catapult they put together with some logs and ropes and stuff like that. So here's where the zero product property comes into play with the real life. All right, we've got this. Here's a quadratic. H of t equals negative 5t squared plus 27t plus 18. After working with quadratics for a while, and just most functions in general, some of you might recognize, look, you know what that 18 is right there? Plus 18? Well, t here is time. And did they say anything about time? I'm assuming it's probably in seconds. Did they say that? T seconds after it was launched, okay? So if you look at when 0 seconds have gone by, this will be 0. That all gets canceled out. This will be 0. Guess what you have? It's when x equals 0, or t in this case equals 0. It has a height of 18. So what does that mean with our Ewok catapult down here? That plus 18. It's the constant value in our standard form. Quadratic over here on the left. Well, that is our vertical intercept. So right here, let me tell you what 18 is. 18, if you guys think about what does it mean when you got 0 seconds have gone by with this catapult, 18 is going to be the height of the rock when they fired it. Let me see if I can't write this down without moving everything out of the way. Get a decent looking 18 over here. I'm struggling. The struggle is real. Right there. All right. At time was 0. These guys, these Ewoks, they must have fired this thing from 18 feet up in the air. All right. So it's not really to scale for this example. Maybe they're on a little hillside, right? We know the Ewoks are pretty short. So maybe they're on a cluster of rocks down here. And that's what made that height of that projectile be 18 feet when it was fired at 0 seconds. So there's my vertical intercept. Let's drop that right here. Vertical intercept. That's when time is 0 seconds. This thing was fired at a height of 18. They're saying meters, whatever. So they're on a little hillside or something. They're above where the rest of the ground is at. The important thing to know is that's the height of the object when it was first fired off. All right, 18 meters. There's our vertical intercept from the constant value in our standard form. Now let's find the zeros, right? We want to find out when this thing hits the ground. So let's say we've got the the walker, right? There's a big thing right here. I'm not a great artist, but you got your thing walking over here. And they want to fire this rock and strike that thing. And we're looking at when is it going to hit the ground over here. When is it equal to 0? When's the height going to be equal to 0? Well, the way we find out, see, this is a height as a function of time. So the way to find out when the height is 0, we've got to get this equal to 0 in here. We got to get that equal to 0 in there. And this one right over here is going to tell us when it hits 0. So I'm looking for my zeros here. The easiest one to me, I see that I'm going to need a fraction right here. So I'm going to go for the easy money first. Look, t minus 6. I know what something minus 6 equals 0. 6 minus 6 would be 0. So if we make x equals 6, let's put it over here. 6 meters. If we plug in 6, oh no, I'm sorry, not meters. Yo, we got time down here. Big mistake. Our height is in meters. But over here on our horizontal axis, we are looking at seconds. Maybe I'll put that in orange. We need to get a different color here. After 6 seconds, this thing's going to hit the ground. Down here, instead of X, what we've got here is time in seconds. All right, so after they launched that thing, it flew through the air for 6 seconds. It was flying through the air just like this in a big arch, a parabola. And then boom, it struck the ground after 6 seconds. Now let's take a look at this other one here. What's that other 0? So I could write down here, and we got what we're using orange for the horizontal intercepts. Horizontal. I always think about the horizon. If I forget what horizontal means. When you look at the horizon, you can watch the sunset or the sunrise. Horizontal. It goes left and right. Intercept. Let's just put INT for shorthand, so this video isn't too long. 6. So when when t for time equals 6, we can list our 2 coordinate pairs here. When time is 6 seconds, the height will be 0 meters. And what about this other one? It's not quite as convenient for us. What do we got over here? We've got negative 5t minus 3. And what are we doing? We're going to try to make this equal to 0. If we can make negative 5t minus 3 equal to 0, we're going to know where our other horizontal intercept is. So I'm going to do my inverse operations. I'm going to add 3 to both sides. And I get negative 5t equals 3. So now I got negative 5 times t. I need to do the inverse operation. The opposite of division is, or the opposite of multiplication is division. I'm going to want to divide by 5. And be sure you take that negative with it, okay? We're looking for positive t, not negative t. You could divide by 5 and then multiply both sides by negative 1, but that's 2 steps. Let's take the negative with the 5 over there. But if we divide one side by 5, we got to do the same thing to the other. And guess what we got? We got t time equals negative 5/3. So I'm going to write that down here in orange with my other horizontal intercept. When time is negative 5/3, the height will be 0 meters. So let's put this in our graph here. Look, that's back over here. Time is negative 5/3. And we haven't talked much about this, but I just want to mention to you guys about the domain of this function. Okay? When you're dealing with a catapult, you've heard about domain and range, right? The range is all the possible values that go up and down. It's never going to be negative, okay? This thing's going to hit the ground. We're not going to, I guess in real life there could be like a hole, or it could go into like a well or something. But in 99% of the situations, it's just going to hit the ground, okay? So it's a safe bet to say that our range has a minimum of 0 and a height of whatever the maximum of this parabola is. And let's get to that shortly. We'll figure out how to calculate how high this thing got just from the information they gave us. All right, let's see. Okay. Now, with time, domain, let me tell you something about domain with time. Usually, in most situations, when you're talking about something that's being fired, like a projectile like this, something's being thrown. Most of the times when we're dealing with parabolas, it's got to do with somebody throwing a football, hitting a golf ball, passing a baseball way across the field, shooting a watermelon out of a catapult like this. In this case, we got these Ewoks who are going to fire this projectile rock out there like that. So in these situations, when we're talking about domain, we do not care about negative time. We never look back. We always look forward, okay? So domain, which color should I write that up in here? Let's maybe in purple. Let's start filling this out. The only thing we care about for this domain, all the possible x values, or the t for time and seconds that could represent the flight of this catapult, this projectile being fired from the catapult, it's going to start at 0 seconds. Because we don't care about yesterday. We're not looking backwards. All we care about is the second they fired that thing. We're not worried how long it sat there, how long it took them to drag the catapult over to where they were going to fire it or put it together. We're not worried about any of that stuff. All we care about is that 0 second when that thing fires off, and we get to see that at 0 seconds it had a height of 18 meters. So guess what? That negative 5/3, it's going to help us find our vertex so we can see the maximum height of this thing, but we could care less about the fact that this rock supposedly had a height of 0 at negative 5.3 seconds. It doesn't really apply to this because our domain is restricted from x, or from 0 until we put t in the middle. T is going to be greater than or equal to 0, but less than or equal to 6 seconds. Okay. So the domain, the only thing we care about for our domain for this projectile is 0 to 6, because we could care less about negative time. All we care about is the present and the future. It's good advice for life as well as math. All right, now let's talk about on the range. We started our range, so I might as well throw that down here. The possible heights that this projectile could reach. We know at least it got up to 18 feet, but knowing the shape of a parabola, we know it's probably going to get them higher than 18, but we know it's going to reach a minimum of 0, because we're probably not going to shoot this thing into a well or some crater or hole. It's going to hit the ground in all likelihood. So our height is going to be, and we could call it h of t. The height is a function of time for the y value. We know the minimum. Let's find the maximum here. Okay, so we got our horizontal intercepts. Where is the vertex? You guys remember? We talked about the vertex is always right in the middle. So what you would do, I don't think I have time on this video. I better cut it short. I'd like to talk more about this, and maybe I'll make a second video about the height. But we're just going to look for the middle of those two and then find out. Once we can find out what's right in the middle, the only reason we care about this negative 5/3 is because we're going to take this value and this value of 6, figure out what's in the middle, plug that in for t for time, and then we'll know exactly the maximum height of this thing.